This problem is about radioactive decay. It's a real-life application of exponential functions and equations. Strontium-90 is a radioactive material that decays according to the function given. The function given is A of t equals A sub 0 times e raised to the power of negative 0.0244t. In this function, A sub 0 is the initial amount of strontium-90 that's present, and A of t is the amount present at time t in years. Assume the initial amount is 500 grams. So we're given that A sub 0 is 500. So the question A asks, what is the decay rate of strontium-90? The decay rate is negative 2.44%. That is given right in the formula. The rate is always next to the time. Notice we changed our decimal to a percent by moving the decimal point 2 places to the right. Question B, how much strontium-90 is left after 10 years? So we want to find A of 10. We'll substitute 10 in place of t in the formula. And now on the right-hand side, we will simplify this. We will now use a calculator, evaluate e raised to the negative 0.244 power, multiply that by 500, and we get approximately 391.7 grams will be left after 10 years. Now that makes sense because this particular substance decays as time increases. So we started with 500 grams. It makes sense after 10 years there would be less substance left. So in a complete sentence we can write, after 10 years there will be approximately 391.7 grams of strontium-90 remaining. Last question, when will 400 grams of strontium-90 be left? So in this case, we know what A of t is. It will be 400. We do not know what t is. So we're going to substitute everything we know except for the variable t. Now let's isolate the term that has the variable t. Let's divide both sides by 500. We can rewrite this equation this way. Now to get t by itself, we can take the natural log of both sides. So the part on the left remains as natural log of 0.8, and on the right it's negative 0.0244t. Let's divide by that coefficient of t. And now at this point we can use a calculator. And we say approximately 9.13 years. In about 9.13 years, there will be 400 grams of strontium-90 remaining.